Hey, this is Steven from LegitTechTutorials and welcome back to my product development series. We are back doing the voiceover for part number 5 of the Tripteron 3D printer build. And in this video, I don't quite remember, so when we get going I will probably remember what I did in this video. So just go ahead and keep watching. The video is about 35 minutes, so we're going to wait to see something that see when something happens here, and then go from there. So actually I think this was when I figured out to getting the stress right, so let's go ahead and just talk about that. So here it's saying static stress. I don't know exactly what the load was, but we have a max flex there at the end of 1.248 millimeters, which is not very good. And I believe I was modeling this as ABS, and ABS is quite a bit more flexible than PLA. PLA is a lot more stiff. So, sorry about that. Let me escort my cat out. She's being really weird today. So last few videos we've been doing the stress analysis of the different of the parts to see what we would get in a actual run, and to see the type of stiffness that we were going to get, so that we know kind of even just under standard gravity loading what type of flex we were going to get. So now what we're going to be doing is building the second arm, because we need that to finish the assembly. And so what we're going to do is extrude out of one of these pieces. Actually, right now what I'm doing, I did already build that, I believe, so I'm just kind of reordering and deleting stuff that doesn't need to be there anymore. So, and also here we need to finish importing in the last piece, which is a fork there, you see, with the 90-degree offset. So we need to import in the fork, and yeah, as you saw there at League Legends, yes, I play League Legends. I accidentally clicked on it, my taskbar. So there we go. We got a rigid joint with the 90 offset and the fork. And actually, just to update you guys on the current status of this project, right now we just finished turning in the last part, which is the stress analysis, and now we are working towards building it. and we have to do a product video, and the product video will be basically a video about the machine, and then we have to be at school 10 days after doing a presentation. So we're about to start taking apart my old machine, my console, and cutting some extrusion and building this particular printer. So we are getting ready to basically start going forward with the project and create the actual machine. That is the current up-to-date status. So I'm about to go back through, and instead of doing what I did on this one or last view, where I basically sized everything by eye, I'm going to go back and parametrically model stuff that's supposed to be a specific size. So now I'm just checking to make sure it'll actually fit. And that's another thing that I'm going to do before I go print, is actually make sure that the right length. If not, so what I'm going to do is model a 3D printer bed in Fusion, lay it down, and make sure that I could actually print it on there. And then I also had some issues with the printer not wanting to print some of the filament that I already had, so I actually ordered some filament that I know would work on it, and so I purchased some Octave, which I know for sure likes to work on that machine. Which on that machine I was using a Proto Paradigm, and the MakerBot 2 likes to not print that stuff. It just likes to clog it. So here I must be talking about something having to do with the total length. And also, as far as the project goes, be getting full marks on everything, so been pretty good. And there's quite a few parts. There is the kinematic. So what we had to do is the project proposal, kinematic, kinematics of the machine, which is basically the equations of motion, of position, velocity, and acceleration. Then we have geometric, which is pretty much the design of the printer, of it set up. So that's what we're working towards in this video, is the geometric design, where we show an exploded view of a mechanism, so just one arm, and then I show exploded view of all the bearings coming out and the joints, blah blah blah, this and that. Then we have the full machine view, as well as that's in the geometric. Then we have forces, which the forces on this machine are the weight of the entire mechanism on one of those members and see the deflection. Then we have the stress, which the stress of that, which we just turned in yesterday. And then we have the product video, and then we have the summary, and then we have the in-class presentation. So in real time, we are up to the just did the stress now, or to the product video, or like I said, in 10 days we have to have this guy built and taking a video of it. Alright, so it looks like we're starting to drawing. I think I'm going to model on top of something that I need to have in there. Probably doesn't look like I've done the effector or the shoulder. So let's see which one I do. Okay, so yeah, I'm basically remodeling over the effector because, like I said at the beginning, I've had quite a few issues with STLs. I can't actually joint off of STLs or even do any sort of sketches of STLs. And also you can't even snap some of the sketches that you do to the STLs. So you basically, and then if you try to convert it, it says that all the STLs cannot be done because they are they're triangles. And then, you know, of course they're triangles because STLs are generally geometrically driven triangles, or mathematically driven triangles. And it's either that, or it says that it's too many triangles or whatever. So you have to import it and draw over it, just like I've done in the last few videos. And also, you see here it's got a few holes there for the get a few holes for the hot end to bolt on there, and also you see that groove mount half. That is what attaches to your hot end, and then attaches to that piece. Now that should work for the E3D V6, so I'll also print that most likely as well. Some of the stuff I'll print at home. Some of the stuff I'll print at Tech Shop. The reason being is I probably want to print everything at Tech Shop just so I get the consistency with expansion, so that you know, everything is the same size. And then here I'm seeing right now if this effector is actually going to work in my particular design, or if I have to reorganize how the things come together. So I basically flip it around until I get it to work, and then basically, spoiler is that I do find a way to get it to work, is I actually flip it upside down 180 degrees, and then as you guys see there, it would work. So with that, that means that we could use that particular model, and we just have to either just print it, which in my case I'm probably just going to print it. I'm not going to do anything weird to it. I'm probably not going to modify it or anything like that. I'm probably just going to straight print the STL that was given in the kit there. And I'm going to do that for a few things. I'm going to do that for the shoulder, the effector, those groove mount halves that you see on the left hand side. The motor mounts are also just going to be printed straight. The motor mounts I could actually print at on my machine at home. So yeah, the motor mounts, the shoulders, the extended shoulders, the effector, groove mount halves, belt spacers, maybe some gussets, some 2020 gussets, 3D printed gussets. Pretty much most of the printer, everything, I'm just going to print everything out of the STLs that aren't the arms, pretty much, because the arms are fully 3D printed. And so it's mainly the arms that I have to go back and check to make sure that everything is correct, because as you see, so let's talk about, I'm doing everything by eye, and so that could lead to the bearings not fitting in there. So what I'll probably do is size it, print it with the filament that I'm going to print the rest of it with, stick the bearing in there, see how the bearing fits, and if it doesn't fit very well, adjust, or if I'm running out of time, just have to print it and then maybe do some sort of glue or something. And then the guys are also talking about preloading, which I'm not very familiar with. So they're saying that they need like a washer for these two bearings to preload them, so that we lose a lot of the give at the end, so a lot of the sag. So that's going to go inside, and that is probably going to be machined by one of the team members to size out of aluminum. And then with that, we will have a lot better resistance to flex or racking in the printer. And after that, I mean, all these guys should be exact. They're using 608 ZZ bearings, you know, standard. I have a whole bunch now, because the person I bought it from actually sent me one set and then sent me another set. So I have two sets of bearings. So you see there are a few of the STL parts that will be used. That will just be printed straight. And we will have to get a few pieces of hardware, like some fender washers, some M8 bolts to go through and through the bearing. A few different things that fender washers, M8 bolts, maybe a print bed would be ideal also, so something like that. But I was thinking for the demonstration, if I can't get a print bed in time, was just print straight on the table in the classroom with just some blue painter's tape stuck on the table. So either what would be ideal is either like a 3/16 inch aluminum plate, some glass plate, or something like that. That would be ideal. I've always wanted to start printing on glass. People have been printing pretty well on glass with no other prep, just printing straight on glass. no glue or anything like that. So that would be pretty pretty nice to try. And others have just printed on glass with, you know, hairspray or PVC glue or whatever. So pretty much for the rest of this video, I just resketch over the effector here, the end effector, but I believe I don't get all the way through and have to go on to another video to finish it. So just tracing this this geometry, just like any other geometry. We've been doing a few different strategies as far as how I went about doing it. What I did is I ended up doing just the inside instead of what I'm doing now. I did just the flat part. That's one extrusion, and then I extruded that, and then I started another sketch for each of the arms. So another 2 additional sketches for each of the arms. And then extruded those, and then went in and did the pieces that were coming out in the middle. And then from there, just extrude those towards the printer, so towards the effector. So start from the outside of those arms that you see them going around right now, and then go in to this corner. So basically, with that corner, I just have it as a just a corner, and extrude that up to the height of the inside, and then put a canvas on the outside, put a sketch on the outside, and extrude that in for each of the arms. And then inside the arms, do another sketch or plane to sketch on for the little spacers that are in between the two bearings. And then from that, I pretty much finish up in a later video, and you'll see me do a few different things here of, you know, doing one thing and then doing another thing. So that's what I did. Is originally I went all the way around, and then I decided just to extrude the middle, and then do the 2 sides separately. So with that, you guys know what I'm doing here for this guy. So I'll basically leave it at that, because I actually have to go pack up something that somebody bought on eBay that I'm trying to get rid of. So what I'll do is I'll just have the video up to this point as far as the audio, and then you guys could just enjoy the rest of the modeling, and, you know, see how I'm doing stuff and whatnot. So I'm sure most of it doesn't need any explanation of what I'm doing, because I just explained it. And it's basically figuring out the best way of doing this guy pretty close to shape. Not exactly to shape, but pretty close to the eye of the shape. A good representation of the shape. Alright, so this has been Steven from LegitTechTutorials. I'd like to thank you guys for watching. If you like this video, please subscribe for more videos like it in this series and other series as well. Go ahead and enjoy the rest of the video, and I'll catch you guys in the next one. This should be the last one that I need to voice over. The rest of them are normal, so you'll go back in and enjoy the regular content, where it's just straight uploads of stuff instead of voicing over. Alright, see you guys in the next one. Thanks for watching. Take it easy. Peace. Okay.
tutorials, I think